Hello everyone, I'm Harsha, and we are Robotics, our rookie team, here today to talk to you about engineering problem solving. This is our team, and we have varying amounts of experience ranging from 0 years to 3 years. Also, since we're a community team, we have people from all different schools and backgrounds, which can really help us when we want a new perspective on things. Our team's mission is to grow as a part of first STEM community, and our goals went from just forming a team, building a robot that can compete at all, getting our team and our rookies trained, to forming a team with great dynamics, building a robot that could compete well during the season and off season, and getting all of our new rookies competition ready. One of our team's innovation is our intake, which is surgical tubing attached onto the chain, which gripped the pixel up a ramp and smoothly transitioned it into the outtake, which then scored on the backflip.
Hi, I'm Andrew, and I'll be describing our problem-solving process. So first, obviously, you have to decide what the problem is and what is causing it. Once we get that down, we organize as a team and meet up to draft solutions to our problem. Once we do that, we test and see if our solution works and if there needs to be any revisions. An example of this was our wiring problems. The problem was our robot kept disconnecting during meets, so we had to see what was causing it, which were the wires being tangled and unorganized. We decided to label wires and bundle them together locally so that way they wouldn't interfere with each other's connections. Our solution was able to work well and our robot stopped disconnecting, and I'll be passing it off to Sanjay.
During our design and development, we encountered a lot of issues. We documented all the information in a chart so it's easy to follow and understand. On the first column, we list every single subsystem in the robot. On the second column, we list every single problem that the robot had. On the third column, we listed the solutions and actions we took to solve the problems. And the fourth column, we wrote down whether it worked out or not. So we used this chart for our drive system, our intake, our outtake, our arms, and everything. Here are four examples of us using this chart. So for the drivetrain, our wheels interfered with our arm because our arm was mounted too close to the wheels. So we added spacers on the wheels, and this resulted in the wheels no longer interfering with the arm. Then our intake ramp was dragging on the floor. This was because the ramp was placed too close to the ground. So we sanded and moved the ramp several units above the ground. And this resulted in the ramp no longer dragging on the floor, so we can properly intake. Another problem with the outtake was that the pixels could not easily enter the outtake system. This was because the height was extremely short, so we increased the height on shape, and we 3D printed it so that the pixels were able to easily enter and exit the outtake. Finally, for the drone launcher, the drone kept falling off the launcher because it was mounted on the arm. So we mounted the drone launcher separately from the arm so that the drone launcher did not fall.
Hi, my name is Bharat and I'm the driver for Lost Robotics. So this is our old and new design for our intake. Our old design was really bulky and complex and allowed us to not be able to perform many cycles during the competition. Our new and improved design for our intake was surgical tubing which sucked up the pixels up a ramp and into the outtake. This eliminated many motors that were being used in the intake system to one, and allowed us to perform more cycles during the matches. This is our old outtake system, our new outtake system. Our old outtake system was really bulky and unable to deposit the pixels on the backdrop, and it was really easy for the pixels to fall out of the frame. Our new outtake system had holes which allowed us to see if both pixels were in the outtake system and easily deposited the pixels into the backdrop. This helped us perform many more cycles during our competitions.
Hello everyone, this is our team's drone launcher. We encountered many problems while designing this. One problem was that when the plane hit the floor, it slid a couple of feet. So instead of scoring 30 points, it scored only 10 or 20. To solve this problem, we used the problem-solving steps that were showed previously. We gave the tip of the plane, we made it slightly heavier, so instead of sliding, it had a steeper descent and no longer slid. We solved another problem, which is the rubber band tension. The rubber band was extremely tensed, so sometimes it ripped up the plane. To solve this, we made 2 rubber band holders so we could adjust the tension of the rubber band. So some challenges and opportunities we faced. So some challenges. The ramp design was not robust. We could have made more prototypes and we could have tested more prototypes. We had challenges using the vision system. We also had some problems with team dynamics. But we also gained opportunities. For example, we got more exposure to CAD on Onshape and we learned more about Roadrunner this season. Using our troubleshooting skills that we showcased today, we were able to solve many problems this season. Thank you for your time and attention. Are there any questions? No questions? Okay.